So thank you for joining us. My name is Ela and I'm the organizer of the meetup. I would like to say a big thanks to Amit and Emma from Amazon and Ming for accepting our request to come here. Thank you. Afik and Daniel from Evicor was here to present too. And honestly, I'm very excited to hear the talks of this meetup and the next meetup. So welcome and enjoy. Thanks. Amit.
Okay, so hi, good evening, everyone. My name is Amit Schwartz. I am a software development manager in Amazon, part of the Alexa machine learning platform team. Me and Ming are going to present Alexa today. I will give a zoom out about Alexa, how Alexa is working, the different algorithms that run inside Alexa, a little bit about the sequence and data flow, and then we will zoom in and drill down into the wake word algorithm, and Min will do this part. Okay, so Alexa, what's playing? So what are we going to talk about? We're going to talk about what is Echo, what's Alexa, what is Alexa skill kit and voice service, what makes Alexa tick. This is going to be the main part. And then we're going to go quickly about what people are saying about Alexa and what will you ask. So let's start with Echo. What is Echo? So Echo is a Wi-Fi connected device designed for voice interaction. As you can see, it has 7 microphones that allow it to hear you even in very challenging acoustic conditions. It has a pair of speakers, woofer and tweeter, that provide 360 degrees surround sound. And it is connected to the Alexa voice service in the cloud. And with Echo, you can do different things. You can listen to music. You can play a music by song, artist, genre, from Amazon Music, Spotify, or Pandora, or any other place. You can play audiobooks. You can listen to radio station, hear news brief from different providers like BBC or NPR News. You can manage your task. It is connected to your Google Calendar, and you can create meeting. You can manage your to-do list, set alarms, set timers, ask for the weather, for traffic report. You can call people or send messages hands-free. You can create shopping list. You can ask any question, general question. Alex, she knows a lot of things. If you have automation, you can control your smart house with Alexa and many, many more things. So let's start with a short clip that shows all of that.
Say hello to the all-new Echo. It's everything you love about Echo with a brand new look and a brand new price. Echo connects to Alexa to play music, call friends and family, control smart home devices, and more. And because Alexa is in the cloud, she's always getting smarter and adding new features. Echo comes in 6 unique styles designed to blend in or stand out. And with immersive 360-degree audio, it can fill any room with crisp vocals and rich bass. 7 microphones help Echo and Alexa hear you from any direction, even when music is playing. All you have to do is ask.
Alexa, play my Sweet Victory playlist everywhere.
Okay.
Alexa, turn it up.
Alexa, play my messages.
Hey babe, please don't touch the macaroons. They're for the baby shower.
Alexa, what's a macaroon?
A macaroon is a type of small circular cake, typically made from ground almonds.
Whoa! Alexa, remind me to sign Emily up for soccer.
Okay.
Alexa, drop in on the living room. Hey babe, just finished the nursery.
Perfect. Timing. We need to go.
Wait, what?
Alexa, turn on the hall lights.
Okay.
Alexa, lock the door.
Okay.
Okay, man, one more. Alexa, how much time is left on the pizza timer?
There are about 4 minutes left on the pizza timer.
Okay, you're on.
Party time.
Excellent.
The all-new Amazon Echo.
Okay, so Alexa is getting smarter every day. New capabilities are added constantly.
Introducing Echo Plus. It's everything you love about Echo, now with a built-in smart home hub. Echo Plus.
Okay, sorry. So we are adding more and more capabilities, and just ask Alexa to control your TV, request Uber or order pizza. It can do a lot of things. So, okay. So what is the Echo device design? So the philosophy is to keep the design simple, implement features in the cloud when possible, and make the device application agnostic and the application agnostic to the device. So basically you can run Alexa on any Echo device or even third-party devices that use it. In the Echo, we have few functionalities or features. We have the wake word engine. We're going to talk about it soon. Bin forming, echo cancellation, audio streaming, and Bluetooth and Wi-Fi. So it's very, very simple, and most of the logic is implemented in the cloud. This is the Echo family. We have the Echo Dot, which is like the Echo, but with simpler speakers. The Echo that we just saw, this is the Echo Plus, that contains also an IoT hub built in. So if you have home automation, you can control it from there. It has Zigbee and Bluetooth capabilities to control your home devices. We have the show here on the right, which is also has a screen, LCD screen, that you can also receive information, not only voice, but also see picture and interact with it. So if you ask for, I don't know, for play the Beatles, it will show you a list of the Beatles records. Then you can select a record and track and interact it either by voice or by touch. And this is the new Echo Spot that is going to be released at the end of the month, I think. Going to be already released. We're going to be available at end of the month, which is like a small alarm clock near your, you can put near your bed, and you can have video chat with it. You can interact with it. It's a very cool and nice device. So what's the difference between Alexa and Echo? Echo is actually the device, and Alexa is the software or the service that runs inside. You can find Alexa also in other places. So for example, we just released a Fire tablet, which works with Alexa, so you can interact with it hands-free. Fire TV, I think, already supports Alexa as well. We have integration with different speaker vendors, and BMW just released Alexa integration, so you can drive your car and interact with it using speech. So now I would like to explain how Alexa is working. So let's walk through the sequence of events that occur when user utters a phrase such as, Alexa, what is the weather? Okay, so at the beginning in Alexa, in the device, we have a wake word engine. This engine listens all the time and waits to hear the word Alexa. Okay, once it hears Alexa, it will stream the utterance to the cloud. Okay, you can see once you say Alexa, you're going to see a light on the top of Alexa, and then it will send the information to the cloud. And it will reach the speech platform. Okay, the speech platform will send the voice to the automatic speech recognizer, ASR, and the ASR will be responsible to convert the data, the sound, into text. Okay, the ASR will return actually multiple results because it's with different significance. So it will return the n best results for this voice. Okay, the recognition result. Once we have the recognition result, the message is sent to the NLU. NLU stands for Natural Language Understanding. Here, these are the algorithms that run and try to understand what the user meant. Okay? Later we will drill down into each module. The NLU, the first thing we need to find is what is the intent classification. That means what the user wanted to do. In our case, what's the weather? It's a weather forecast intent. Okay, there are different type of intents. So it will find what is the intent classification, and also add all the relevant attributes to it. Okay, so the NLU will return an intent, and then the speech platform will send it to the relevant skill or application. There are many, many skills and many, many applications. Each one knows how to handle specific type of intent. Okay, and in this case, it will send it to the weather forecast application, and that will return a speak directive that contains some kind of text that explains what is the weather today. Okay, the text will be sent to the text-to-speech engine, TTS, that will return a voice. Okay, the text-to-speech, we send something called, as you can see, it's called SSML, which contains also not only the text, but also metadata about the text. For example, is it a question so Alexa will not be sounded like a robot. It will sound like human. So you can add emotions, you can add to explain Alexa how to pronounce this sentence and how to say it. This information will be sent down to the Echo device, then it will return the reply. Everything will happen in milliseconds, very, very fast, and everything will be done in parallel. That means the ASR will return multiple results. The NLU will also return multiple results because maybe the question is relevant to multiple skills. And the speech platform will need to rank and find what is the best match based on the score that each one returns and based on the context. Okay, so the speech platform also manages the session and the dialogue. So if you have a conversation with Alexa, it knows the context and dialogue. And sometimes, for example, if I ask Alexa, what is the weather? And then I will say, Alexa, and tomorrow, it will automatically know that you are asking about the weather in Boston. Okay, so there is a context of the message that the speech platform is managing. Question about, yes?
So all this is in cloud?
Everything is in the cloud. So this is not in the cloud. So the Wake Word engine is on the device itself. Just listen to the word Alexa and the sentence that come afterward, and it will send the voice to the cloud. Everything else is done in the cloud.
So for the dialogue manager, how do you deal with it knowing when you ask a question, like you know that it's talking to something new, or referring to the context from the previous question?
So this is the dialogue in session. We keep the context. We save the context, and so every time you ask something, there is a session. So when you follow up with a question, we see, okay, are we still part of the session? And then we look for that information.
What if like a person has to ask a new question? Can you tell that they're asking something new versus something?
So I'm not part of the dialogue management, but I can tell you that usually there is a time factor. So it checks if it's relatively close, okay, to the previous question, and also if it's relevant. If it's a totally different question and the dialogue information is not relevant, then it's not relevant. It will not use it. Okay. So now let's look on another use case. This time I will tell Alexa, play Message in a Bottle by Sting. Okay. So the beginning is done the same. The Wake Word engine will listen and hear the word Alexa. It will forward the voice to the speech platform. The speech platform will send my text to the ASR, the automatic speech recognition, that will return a recognition result. That will be sent to the NLU. NLU stands for stands for the natural language understanding. It will say that this is a play music intent. Okay, it will say that it's a play music intent, and I'm looking for a song called Message in a Battle by an artist called Sting. Okay, I can tell you that here in the background we also have catalogs of information, that we have all the available song and singers, so we can identify if this song really exists or not. And if not, maybe we will suggest and provide another song by Sting or something like that. But it also uses a catalog. We have many catalogs for many different subjects. And it will go to the play music application or play music skill. And the play music skill will not return a speech, it will return a URL. Okay? So it will return a play directive that will be sent to the Echo device. The play directive contains a URL, and the Echo device will download the song from this URL and play the song. In parallel, the Echo device is sending events to the speech platform. So, for example, there is a playback started, playback nearly finished, and playback finished event. And this is a very interesting point that I would like to talk about. And it's interesting to see that the Echo device is not aware of a playlist or what I'm asking. Okay, and this is part of the philosophy we told, that we will keep the Echo device as simple as possible and we move all the logic to the cloud. So before the song ends, it will send a playback nearly finished event to the speech platform. The speech platform will call the play music skill. Play music skill will say, okay, so the track 1 is about to end. Let's play track 2. It will send a new play intent to the Echo device. Okay, so while the song is playing, the Echo device will start to download the new song. Okay, and then when the first song ended, the second song will start automatically, without any, quickly, and everything will, because it already downloaded it in the background. And the Echo device is as dumb as possible. All the logic is in the cloud. Okay. Yes.
So how much state is it keep track of? You say to it, play the song. And while the song is playing, you say, play something a little more upbeat. Is it able to figure out what song it was playing? Does it have enough history to go do something like that?
So again, I'm not proud of so there are, as you see, it's very modular, and there are different tips that handle different things, different skills, and I'm not working on the Amazon Music part, but there are a lot of, again, our goal is to have a frictionless experience. So if you will ask for a song that does not exist, okay, it will find, let's say I ask for a song by Sting that doesn't exist because he didn't understand me. It will offer you, would you like to hear this song by Sting? It will try, it's called recovery. We try to provide you an answer. We try to, we know, for example, what you listen to before, what you like. Sometimes when my son talks to Alexa, I have a 3-year-old one, she tells him, this is a song you might like. Okay. Last week we even released the speaker ID features, so we know your preferences, not only by account, but by a person in the family. Okay, so we try to make everything smart. I don't think we have models per person, but we use the data that that you speak to Alexa. We use it to train our models, and we have many models for different regions and accents, etc. There are some even, I think there are also some personal models, depends on, your audiobooks and things like that, but not for ASR. So I think for shopping, you need to enter a password. I think you need to approve it from the application. There is no authentication in Alexa yet. Okay, I'll move on. We have more question at the end, okay? Alexa is voice-centric, but it's not voice only. There are some applications that have a web interface, okay, either the mobile application, the Echo Show, or the Echo Spot. I will go quickly. Alexa knows a lot of things. So you can ask a simple question like, how tall is the Golden Gate Bridge, sorry. This is a simple question to answer. But you can also ask more complex question like, who was the president when Queen Elizabeth was a teenager? Okay, so in order to answer that, Alexa first needs to find who is Queen Elizabeth, how old is she, when was she a teenager, and then find who were the president that time. So it knows also how to answer complex questions. Alexa Skill Kit, it's basically the way for third party to add skills to Alexa. So it's a set of APIs and documentations and your ability to develop your own skill, and then deploy it to Alexa. I think we have more than 25,000 skills, and the number is growing. For example, I'll give you an example. This is a StubHub. Okay, so Alexa, ask StubHub what is going on tonight.
I found several events in Boston in the next 7 days. Here are the first few. 1. Zed at House of Blues on October 18th. 2. Fun Home at the Boston.
Alexa, stop. So this is an example of an integration, okay, that StubHub developed, and there is a skill set that many people can develop. We have, if you want to order pizza, Uber, many integrations that basically call API on the StubHub, to the StubHub services, and they can extend and add functionality to Alexa. Another way to integrate with Alexa is with the Alexa voice service. So this is if you manufacture any device that has mic and speaker, you can integrate Alexa into it. Okay, so we see some microphone manufacturer are now embedding Alexa into it. Alexa is being added into cars, etc. So these are two different ways that you can integrate with Alexa. So what makes Alexa tick? What makes it work so quickly and so nicely? So one of the core things is the pervasive use of deep learning. We use deep learning everywhere, for example, in wake words, speech recognition, NLU. Deep learning requires a lot of data to train the deep network, neural network. And I'm part of the machine learning platform team, and there are thousands of servers that are calculating thousands of machine learning algorithms all the time on a lot of humongous amount of data. Algorithms are being deployed every day. Some algorithms are calculated and deployed daily, trained and deployed daily. So behind Alexa, there is a humongous amount of data and compute power that supports it. And this is why it also grows and new functionality is added and it is improving every day. So let's talk about some of the algorithms we use. Again, it will be a little bit high level. Later we will dive deep into one of them. The first thing I want to talk about is beamforming and acoustic echo cancellation. Okay, so this is an algorithm that runs on the device. So let's press play. So Alexa is playing a music and someone is saying Alexa. You can see that it's very hard to understand what he says. So the beamforming and acoustic echo cancellation basically clears the data and leaves only, mostly clears the sound that Alexa is doing, the music or the speak that Alexa is doing. So now it sounds, this is how it sounds after the algorithm is running. Okay, this is done also using deep neural network. Another thing is the wake word detection. Okay, we listen to a lot of words. We need to identify when someone says Alexa. There are many challenges around the signal quality. For example, the sound noise ratio can be problematic. They are competing. There are more sounds in the background, music playback, pronunciation. Different people pronounce Alexa differently. There is something called accuracy versus latency. We want it to work very accuracy and very fast, which is very challenging. I'm not gonna we're gonna talk about this algorithm to the mathematics behind it in a few minutes. The far field, the ASR, the speech recognition, is also another challenge. The acoustic challenges are the same as the wake word, okay, low SNR, etc. There is a large vocabulary of words. Okay, it's not only the words from the dictionary, it's also, think about it, all the songs, movies, sports events, sport teams, anything that happens in politics. So the vocabulary is changing and growing. Artist names are sometimes not standard. We compare the names to the name of to a catalog. Okay, and sometimes in the catalog, for example, Pink, this is how she writes her name. So it's very, very challenging so there are many, many challenges. So also the catalog data is not always so easy to use. And there are also a confusing title. For example, Sundays versus Sunday. And it's very, very hard to find all these issues. So we run mainly neural network algorithms for ASR, but also additional statistical models to resolve this issue. Natural language understanding, also to understand what was the intent of the user. Also here we have many algorithms around understanding what they want. So sometimes there is cross-domain intent. So for example, play remind me versus remind me to go to the play. It's the same words, but totally different intent. And I can tell you that Alexa will try both of them. Each one will return a score, and this is how we select what to use, or it's going to be based on the context. Robustness of ASR errors. So let's say user select play songs by Michael Jackson, but the ASR can return play songs by Michael Jackson. Okay, so there can be spelling mistakes. Okay. So another problem with the natural language understanding is that there is no UI. So we need to be very accurate. We cannot present you 10 results and you will select, okay, I want number 3. We need to return one result, and that result should be the correct one. So it's very, very challenging and hard. So we run, for NLU, we use combination of statistical models, of rules, which are FSTs, graphs that we build to understand the language based on the language rules, okay, and also neural networks. I will skip that. Dialogue management, I think we talked about it. We have different error recovery strategies. For example, if you say Alexa, Bruno Mars, I didn't say what, okay? But it will check and see statistically that Bruno Mars, usually you don't want to see the Bruno Mars value in Wikipedia, you want to hear songs for Bruno Mars, and she will tell you, okay, shuffling song by Bruno Mars. Okay, so there are many error recovery strategies based on your preferences and other preferences. What people are saying about echo. So this is from the media. There's no gadget dream greater than this. Your wish is my command. I don't think I can go back to remotes and apps after trying the Echo. This is how controlling music at home should work. Controlling, now you can also control the TV with Alexa. I just spoke to the future and it listened. Okay. Our customers, we have a score of 4.5 in Amazon. It's life-changing. Echo saved my mother's life. Echo is changing my life for the better. Most quality of life improving tech I have ever bought. So people really, really love it. And this is the interface of the future. So now, if you have any questions.
I'll try to bring the microphone because we are capturing.
Yes, you mentioned for the skills kit, there's 25,000 skills currently. And how does my skill, if I want to add a skill to Alexa, how would it get selected over one of the other 25,000?
So I think that today, one way is that there is an activation word for skill. For example, for StubHub, I said, Alexa, ask StubHub what is going on tonight. So I directed Alexa what skill I want to use. So this is how it's done today. We are working on making it more natural and more easy. This is what I can say.
Excuse me. What kind of neural net algorithms do you use? Convolutional networks? And the other question is, what do you use in the back end? TensorFlow, your own, etc.?
You want to answer that? So, Ming is from the science team. I think he can answer more accurately.
Maybe when Ming will give a more technical presentation later. Who else?
Hi. So for your intent detection, like when you get it wrong, how can you tell? And do you have triagers who label the data again when Alexa predicts the wrong intent?
So, first question: how do we know that we were wrong? This is a very good question, and it's another thing that we work on finding. So, one thing is, for example, if we ask something and you immediately, after 1 second, you ask something else. There is something we call sentiment. We can measure, your sentiment, if you're happy or not happy with the result. You say, Alexa, stop. Alexa, no. So there are things there are some signs that we use to find, is it an error or not?
Hi. For the beamforming and the acoustic echo cancellation, did you say you use neural networks for that too, or do you use signal processing techniques on the device to kind of solve them?
You want to answer this?
Yeah, I think nowadays the mainstream is to switch to neural network. But we couldn't let you know the exact algorithms we are running. But as you may see from everywhere else, people are switching to the neural network for these kind of tasks.
How much?
Yeah, last question, and then we'll have another.
How much do you, if at all, do you use the history on the device to help with speech recognition and intent recognition, or if at all? So if I always want to order pizza instead of listen to music or whatever, how much do you or does it, have you just found that it doesn't pay to do that because
it depends on the domain, but I will give an example of shopping. Okay, Alexa Shopping is one of the domains, and their goal is to be your personal assistant. They want to know everything about you, what you like. And when you will want to buy a pair of socks, they will already know that, or toilet paper, they will already know that last time this is the brand you like, and they will offer you the same thing. So I think it depends on the domain. And for example, shopping, their goal is really to know what you like and what you prefer. And they will collect the information about you to help you and to provide you, because again, it's not Amazon that can provide you 10 options. We can provide you 1, maximum 2 options. So really to help you and to be your personal assistant as much as possible. Okay, thank you very much.